Part 5. How light reaches us in the future. The blue line in this graph is the proper distance from us of the light wavefront that reaches us when the universe is 150 billion years old. Light from the first stars will still be arriving, though with a redshift of 130,000 radio waves and very dim. The solid purple line is the Hubble distance. This saturates at 5340 megaparsecs at the upper right, as expansion is exponential and we're assuming constant dark energy density. The dotted purple horizontal line represents the event horizon at 5340 megaparsecs. Note that the blue line is beyond the Hubble distance before 38 billion years, and then crosses inside the Hubble sphere. At that crossing, the proper distance is 5320 megaparsecs, which is inside the 5340 megaparsec event horizon, and we will eventually see that light. This light spends about 30 billion years near 5320 megaparsecs away from us. The red curve is galaxies that are 100 megaparsecs away from us today. 130 times Andromeda's distance. They will pass the Hubble distance and the event horizon when the universe is 82 billion years old. Some of the light that they emit hundreds of millions of years before they cross the Hubble distance will reach us when the universe is 150 billion years old, with a redshift of about 50, so shifted to infrared. Other light that they emit immediately after crossing the Hubble distance, but before crossing the event horizon, will reach us much, much later and further redshifted. At 150 billion years, no galaxy beyond our Milky Way Andromeda local group will be visible to us anymore in the visible range, and later not even in the infrared range. But we will continue to see Milky Way Andromeda stars until they stop shining.